yesterday, not yesterday, in the previous lecture we have seen indefinite sum. Yes, and its properties. Okay, and we have seen theorem also. Let a be constant, then for delta c of t is equal to 0, we will have summation a raised to t is a raised to t upon a minus 1 plus c of t. Similarly, summation sin at will be this one, cos at will be this one, summation log at is log gamma t plus c of t. Summation t to the a falling is t to the a plus 1 falling divided by a plus 1. This also we will use many times, so remember this. Summation t to the a falling is t to the a plus 1 falling divided by a plus 1. And this one, summation tca is nothing but t c a plus 1 plus c of t. Also, we may use this d. Summation a plus t c t is nothing but a plus t c t minus 1. What is this c? C is a, which is notation? This is, everybody familiar with this notation, right? This is
Yes,
not
ma'am.
just bracket.
Yes, ma'am.
This is TCA combinations. Okay. So now I think everybody might have did this homework. I given this as homework. Just you have to take delta on both sides and use the formula for a delta operation and show that LHS is equal to RHS. Right. So
Yes, ma'am.
now we'll start today's lecture. So we will start with example. Whatever theorem we will prove depending on that example is there. So find the solution of difference equation y at t plus 2 minus 2 times y at t plus 1 plus y at t is equal to t to the 2 falling. And what is the domain of y? It is t is equal to 0, 1, 2 and so on. So domain is integers. So that now initial value, boundary value has been given. Y at 0 is equal to minus 1 and y at 1 is given to be 3. Okay, it is boundary value problem. So in yesterday's lecture we have seen this problem. Delta, this is, what is this side? This is my
T into T minus.
what is this side?
Del square y of T.
Delta square y at
Square of y of T.
right. And this is t to the 2 whole. So this example we have solved. That is the we got t to the 4 falling divided by 12, right?
To 3.
Right. But here now we have given boundary conditions also, and domain has also specified t is equal to 0, 1, 2 and so on. So we will use our theorem and we will derive the solution for this. So it is like differential equation. When we want to solve differential equation, what we do? We usually take, please everybody mute. Pallavi Patil, mute. Yes. So when we solve differential equation, what we do? We usually take integration, right? And then we find solution. Similarly, here it is difference equation. Now we will have summation. Is it okay? Taking summation.
Yes, ma'am.
Taking. We have seen what is summation and what are the formulas. Summation or anti-difference. Anti-difference on both sides, say of 1. Yeah, so what I will get if I take summation on both sides, delta square yt, which is equal to summation t to the 2 falling, right? Now summation applied on delta, it will get cancelled, only one delta will remain. So I will get
Yes, ma'am.
yt is summation t to the 2 falling. Now what is summation t to the 2 falling? By our formula, it is t to the
Three into
r falling, r plus 1
three column. Mm-hmm.
falling divided by
Three.
3,
Plus 40.
right? Divided by 3. 2. What is the formula? T to the a falling, this summation T to the a falling, the a plus 1 falling divided by a plus 1. So it will be 3 only, right? Plus C, constant, where C is arbitrary constant. Why I am not taking C here, C of t here? Because my domain, you can see here, domain of definition is integers, and when domain of definition is integer, that C of t will reduce to C only. Is it okay?
Okay, ma'am. Yes, ma'am.
Yes, so this step is understood now. Delta yt will be t to the 3 falling divided by 3 plus some constant C. Now again I want to remove this delta. So again what I have to do? Again take summation on both sides. Again taking summation on both sides of above equation, or we can say 2 of equation 2. What we get?
Y of t is equals to
Hmm. Y of t is equal to, now if I take summation on both sides, it will be summation t to the 3 falling divided by 3 plus summation constant C, right? And plus some constant of integration D, right? So what is this by formula again? It will be t to the 4 falling,
4
because
following divided
3 is constant outside, and t to the 4 falling into
by
divided by plus summation
4.
C. C is constant, so outside summation 1 and plus D, constant of integration. We can say here D is arbitrary constant. Is that okay?
Yes.
Now what will be this? T to the 4 falling divided by 12
12
C times. What is summation 1?
t
It is T and plus D.
d.
It is summation 1 is T, because what is delta T? T plus 1 minus 1. Sorry, T plus 1 minus
Minus t.
this 1. So this implies summation 1 is nothing but my t.
T.
Is that okay? Summation, if I take on both sides, summation delta will get cancelled. So t is equal to summation 1. So we got solution in terms of two arbitrary constant because it is second order difference equation. So we will our general solution will include two arbitrary constants c and d. Now we have given boundary values also. What are the boundary values? Y at 0 is equal to -1 and y at 1 is equal to 3. Y at 0 is equal to also y at 0 is equal to -1 and y at 1 is equal to 3. No, y at 1 is given to be 3. So this implies what is my c and d then? So can you calculate c and d now? Y at 0. If I substitute 0 here, what I will get? 0 plus c times 0 plus d, which is equal to -1 it is given. So I am getting here d is equal to -1. Is it right?
Yes, ma'am.
And if I substitute, and since y at 1, what is y at 1?
3.
1 to
3.
the
1
4
by
falling
minus
divided
falling
by
1. Divided
12
by 12
plus c
plus
times
C.
1 and d is my -1, which is equal to what? It is given to be
3.
3. So what this implies? C is equal to, what should
C
be
is
C?
equals to 4. 4.
Equal to 4. Everybody got this? What is 1 to the 4 falling? T to the 4 falling. T minus 1, T minus 2, T minus 3. Is it?
Yes, ma'am.
T minus 1, T minus 2, T minus 3. So this implies 1 to the 4 falling is 1. What will be
1
this?
minus
1
1
minus 1,
minus 1.
0. 1 minus 2, 1 minus 3 I can write. So I am getting here 0 only. Correct? 1 to the 4 falling is 0. So C is equal to 4. Right?
Yes, ma'am.
Okay. So what is my particular, so this we can write here which is my general solution. This here, this is general, this is called as general solution. General solutions means if it is second order, it will contain two arbitrary constants. If it is third order difference equation, it will, general solution will contain three arbitrary constants and so on. So which is my general solution? Which is general solution. Now to find particular solution, we need to substitute the values, given boundary values. So with the help of that, we have found now d is equal to -1 and c is equal to 4. So therefore, particular solution required solution is given by, what is the solution then? Yt is equal to t to the 4 falling divided by 12 plus 4t plus, not plus, minus 1. Is that okay?
Yes, ma'am.
T to the 4 falling divided by 12 plus 40 minus 1, which is my required particular solution, or which is the unique solution also you can say. Okay, this is the unique solution. Unique or particular? Unique solution of the problem, given problem. This. boundary value problem. Is that okay?
Yes, ma'am.
So if here instead of my domain was reals, then we might have taken here C of t, where delta C of t will be 0 and so on. Since here now my domain of integration is integers, we have taken here just C, any arbitrary constant. Now we will solve another example. I have to write it or okay. Suppose that each side of the triangle of an upward pointing equilateral triangle is divided into n equal parts. These parts are then used to partition the original triangle into smaller equilateral triangles. So how many upward pointing triangles at n of all sizes are there? So read this carefully. Suppose that each side of an upward pointing equilateral triangle, I will draw here. So I am having upward pointing equilateral triangle. Equilateral means all sides are of same size. Okay. Now it's divided into n equal parts. N equal parts means for n is equal to 1 in one part, for n is equal to 2 in two parts, and so on. So first I will draw this like this is this angle of this. Can you see this diagram?
Yes, ma'am.
So these are all equilateral triangles, whatever I have divided into. Okay. So what it's saying, suppose that each side of an upward pointing equilateral triangle is divided into n equal parts. These parts are then used to partition the original triangle into smaller equilateral triangles. Original triangle into smaller equilateral triangles. How many upward pointing triangles yn of all sizes are there? So for n is equal to 1, what is this? It is just one triangle. It is just one triangle. So what is my y at 1? It is just 1. Are you getting this?
Yes, ma'am.
So for n is equal to 2, n is equal to 2, equilateral triangle. So I want to divide into, each side will be divided into n equal parts, means 2 equal parts. Now you can see this side is divided into 2 equal sides. This side is also divided into 2 equal sides, and this side is also divided into 2 equal sides to get the partition, and we are getting equilateral triangles. So how many total equilateral triangles we are having?
4.
1, 2, 3, 4.
5.
5.
5 no, ma'am.
5
no. Madam, upward pointing है ना?
Upward pointing. So this
हाँ,
triangle you should not take this one. This is also a triangle, but I don't consider this because it is not upward pointing triangle. Okay. This is not upward pointing. Upward pointing are which are upward pointing triangles? This original one first, then this is second, third, and fourth. Are you getting?
Yes, ma'am.
I have to use different colors, or I will. Okay. This is one. Another one is upward pointing triangle. This one. Another one is this one. And original one. Original one is this one. That is also our equilateral triangle. So how many total? 4. This whatever blank I have left, it is also triangle, but it is not upward pointing triangle. So what is y at 2?
4.
Y at
4.
2 is 4. Now for n is equal to 3.
4.
N is equal to 3.
5.
I want to divide into 3 equal parts. Okay. 1, 2, and 3. Okay, now so I have divided each side in 3 equal parts. Now how many upward equilateral triangles I am having? For n is equal to 3.
7. 7.
7
7.
7 only.
8. 8.
This is 1.
7. 10, ma'am.
This is 1.
9
7.
9.
10.
This is
7.
second.
10, madam. 10.
This is third. This is fourth. This is fifth. This is sixth. Okay. 7 will be 7. Now I will draw another color. Now this is also upward lifting triangle with equal size, equilateral triangle.
Yes, ma'am. Yes, ma'am. Yes.
This is 7th one, na? 1, 2, 3, 4, 5, 6, 7th. Then this one,
Actually,
this two,
yes.
and
Yes.
this. So how many?
7, 8.
6 and that bigger 9. And my
Nine.
original one is 12.
9.
9.
10. 3 smaller, like single
8.
pieces,
3, 4, 5, 6, 7, 8.
right? Single pieces. They are 6. Then with double pieces like this, 1, 2, 3. If I take this one and then this.
9, 8, 10.
So this 3. So total 9, and our original one, it is 10. Are you getting? Total upward
Yes, ma'am.
pointing triangles. Is that okay for everyone? And
Yes,
so
ma'am.
on. So on. So now I want to find general solution. What should be my yn? Now if we go on doing like this, it is very difficult to find all the triangles. So we will use here difference equation. So how we will use difference equation? Now what is y at n plus 1? Can you say here? Like from here. Y at n will be what? If I remove last, which color I should take? Okay, now you see up to here only I am considering. So this is my y at n. And what will be y at n plus 1? I have to add this also, na, then. Right? For y at n, I have to add below this also. These are all triangles also. So how many we are getting exactly? So what is happening here? Y at n plus 1 is equal to how many? What is the relation between y at n plus 1 and y at n? Can you tell me? You can see here, this is, if it is n is equal to 1, 1. Then we are adding this below, that 2 triangles, right?
2n plus 1.
Huh?
2n plus 1.
We add this 2 and then again 1 will be added, right? So y at n plus how many? This is our single one. If I add, so how many we are getting? Additional 1 plus 1 is my y at 1. What is y at?
3.
I want to find y at 2 ना. So y at 1 plus काय होत आहे तिथे? हे 2
3.
आणि हा 1. So how many? 1 plus 2 plus 1 is 4 ना, total 4 ना. This one is already there. हा एक ऑलरेडी आहे. नंतर हे 2 आपण ऍड करतोय आणि हा जो मोठा होईल, हा मोठा तो एक ना. Are you getting? Are you getting? For
No,
y,
ma'am.
you see the relation between 1 and 2 first and second case. Okay. For n is equal to 1 this, and for n is equal to 2 this. So for n is equal to 1 we are having only one triangle, right? Now for n is equal to 2, what I have to do? I have to divide into two equilateral triangles. Now each side I have to divide into two equilateral triangles. So what will be my y at 2 we want to find? What is relation? This one is as it is. Whatever earlier, y at 1 as it is. And then how many we are adding here now? This one, and this bigger one, original. So किती ऍड केले मी नवीन? 2 plus 1. कळलं का? नाही.
Yes, ma'am.
मला रिलेशन पाहिजे. I want to find relation between y at n plus 1 and y at n. म्हणजे y at 2 आणि y at 1.
Y at n.
How I can find y at 2 using y at 1? हा y at 1 आहे. हा जो
Y at n.
आहे. Yeah, so हा y at n प्लस काय करायचं मला ते बघावं लागेल ना. मी किती नवीन ऍड करते. नवीन आता y at 3 मध्ये बघा तुम्ही. हे y at 2 आणि y at 1 समजलं का? हे टोटल 4 आले आपले. ओके. Is that okay?
Yes.
Yeah. Now I want to find y at 3. What is the relation between y at 3 and y at 2? So आता माझ्याकडे y at 2 हा आहे. ओके, ओरिजिनल. नाउ मला y at 3 पाहिजे. तर मी काय करेल? Add one more row. Right? I am adding one more row. Now if I add one more row, how many triangles we are adding new? किती ट्रायंगल मी ऍड केले आता नवीन? हा एक नवीन. हे ऑलरेडी जे होते तेवढे ऑलरेडी आहेत. ओके. y3 y2 विल बी ऍज इट इज. y2 चे ऍज इट इज आहे. नवीन कोणते झाले माझ्याकडे? हा एक, राईट? हे 3 झाले. ओके. आता डबल साइडचे कोणते झाले माझ्याकडे? This one is new now. This one is new now.
Yes, ma'am. Yes.
हे किती झाले? 2. ओके. आणि हा मोठा जो झाला ओरिजिनल आता तो एक सिंगल नवीन ऍड झाला. ओके. So what was my y2? It is 4 plus 3 plus 2 plus 1. How many?
10.
It is 10. Are you getting?
Yes, ma'am.
जे नवीन किती होत आहेत ते आपल्याला फाइंड करायचे. जे सिंगल जे होतील ना ते किती होतील? n+1 होतील. जे सिंगल वाले दिस इज सिंगल ऑफ 1 लेंथ किंवा तुम्ही काय म्हणू शकता त्याला, तुम्हाला काय म्हणायचं ते म्हणू शकता. सिंगल लेंथ. डबल वाले किती होतील? n-1. नाही n राईट. एक कमी होत जातोय बघा. आणि जो मोठा आहे तो सगळ्यात मोठा. कळतंय का? 3 plus 2 plus 1. इथे काय होतं? y at 1 plus 2 plus 1. So can you tell me generalized relation now? Y at n as it is plus
n.
इथे 3 आहे 3
Plus 1.
2 आहे 2 आलं होतं आणि मग 1 पर्यंत जायचं. Are you getting?
Yes.
तर काय येईल इथे?
Yes, ma'am.
n plus 1 plus n plus n minus 1
Plus
plus and
2.
so on up to 1.
1.
Okay. n+1 ला मी असं लिहितो. So what is this? This is summation of 1, 2, 3 up to n+1. 1, 2, 3 up to n+1. What is this summation now?
n+1 factorial.
n plus 1 n into n plus 1 divided by 2 असतं ना, तर इथे n plus 1 आहे, तर n plus 1 n plus 2 divided by 2. What is summation? 1 plus 2 plus 3 plus and so on up to n. What is formula? N into n plus 1 by 2, not n factorial. This is my right.
Yes,
Are you
ma'am.
getting?
Yes, ma'am.
Now instead of n, I want n plus 1. Here up to n plus 1 we are adding, right? N plus 1. 1 plus 2 plus 3 and so up to n plus 1. So n plus 1, we will replace here n by n plus 1. N plus 1 into n plus 2 divided by 2. Is it right? Whether everybody getting this?
Yes, ma'am.
Yes.
Yes, ma'am.
So what will be now relation? Now we will get the relation. Y at n plus 1 is nothing but yn yn plus, or I will write this as this side, which is equal to n plus 1 n plus 2 divided by 2. It will be nothing but 1 upon 2 n plus 2 to the 2 falling. I can write हा y at n मी इकडच्या साईडला घेतला. So I will get in terms of delta. Is that okay? And this
Yes,
n
ma'am.
plus 1 n plus 2 I have written in terms of n plus 2 to the 2 falling. And this 1 by 2 as it is. Are you getting this? So this I can write as delta
Y.
at n is nothing but 1 by 2 n plus 2 to the 2 falling. Now we have got in our notation. This is now in our familiar notation. So now if I want to find y at n, what I have to do? Take summation on both sides, right? Taking summation. This is first order difference equation. So I have to take only one time summation. Summation on both sides of above equation. What I will get? Summation delta yn, which is equal to 1 by 2 is constant outside, summation n plus 2 to the 2 falling. Is it right? And since domain is integers, I will consider as C as arbitrary. C is an arbitrary constant. Is that okay?
Yes.
Yes. So what is now summation delta yn? Integration of differentiation. काय येतं? Just that original function.
Delta yn.
It is just yn. 1 by 2 is as it is, summation n plus 2 to the 2 falling. So what will be this? N plus 2 to the 3 falling divided by 3 and plus c as it is. So which is equal to n plus 2 to the 3 falling divided by 6 plus c. That is my y at n. Is it? Am I right?
Yes, ma'am.
Yes. Now I want to find this c. How can I find this c? I am having y at 1 is equal to 1, this value. Yes, initial condition I am having. Now I can find, since y at 1 is equal to 1, this implies, what is my c? 1 plus 2 to the 3 falling divided by 6 plus c is nothing but 1. Right?
Right.
Yeah. So what this implies? What is my C? 1, 3 to the 3 falling divided by 6 plus C, which is equal to 1. So 3 to the 3 falling म्हणजे 3 into 3 minus 1 means 2. What is 3 to the 3 falling?
1.
T to the R falling.
1.
T
1, ma'am.
1.
Hmm.
T 3 to the 3 falling is 1.
Yes, ma'am.
T minus 1, T minus 2 and so on. How T minus R plus 1 na? What will be this 3 to the 3 falling?
6.
3. 3 minus 1.
6.
3
3
minus
minus 2.
then कुठपर्यंत येईल हे? 3 minus 3 minus R plus 1. What is R? R is 3 minus 3 plus 1. एवढंच येईल ना?
Yes.
एवढंच येईल ना? minus 3 plus 1 म्हणजे 2 पर्यंतच येईल लास्ट. Is it? So 3,
Yes, ma'am.
3, this is 2 and this is 1. So it is just 6, right? So 3 to the 3 falling is 6. So I can write here 6 by 6, which is equal to 1. So 6 by 6 is 1. 1. So this implies C is equal to
C is equal to 0.
0. So what is my N? So this implies what is Y at N? What is Y at N from here? N plus 2 to the 3 falling divided by 6. N plus 2 to the 3 falling divided by 6. That is my required unique solution. Required unique solution. My गरज नहीं. Okay. So it is our, which is the required solution. Is that okay? Everybody understood?
Yes,
N
ma'am.
plus 2 to the 3
Yes,
falling
ma'am.
divided by 6. With that many upward pointing triangles will be there. If we divide each side into n equilateral triangles. Is that okay, this example?
Yes, ma'am.
Yes. So we will go further. Next theorem. Theorem 2.6. What is this theorem 2.6? Summation yt plus zt is nothing but summation yt plus summation zt. Then summation dyt is nothing but d times summation yt plus what's my, where d is constant. D is any constant. C summation yt delta zt is nothing but yt zt minus summation ez delta yt and D summation E y t z t E y t delta z t E y t delta z t E y t delta z t is nothing but y t z t minus summation z t delta y t. So this is what it is like, similar to integration properties. Integration of yt plus zt is integration yt plus integration zt. Integration of d times yt is d times integration of yt. Now this is like integration by parts. These two. Are you getting? This is now linearity properties of summation. Summation operator. And this is like integration by parts formula or summation by parts. Now not integration by parts. Now it is summation by parts. It is just like integration by parts. Are you getting this? These are summation properties. Everybody can see this?
Yes, ma'am.
For difference, we have already proved this. Difference operator, difference of yt plus zt is difference operator operated on yt plus difference of zt. Then difference operator operated on c times yt is c times difference of yt. Can you recall? I think in yeah. Can you see here delta yt plus zt, theorem 2.1. It is delta yt plus delta zt. Delta cyt is c times delta yt. Then we have proved this product rule. Delta yt zt is yt delta zt plus e zt delta yt. And D is division rule. So that first three properties, our all that four properties of summation follows. How it will follow? How it will follow? What I have to do? This you can see. These three properties.
Yes, ma'am.
So how it follows from theorem 2.1 now? How I can say summation yt plus zt is nothing but summation yt plus summation zt from this A? Here how we have proved? Like this. Because we know the formula here. But for summation we don't have formula. We have relation between delta and summation. Right? Summation is anti-difference. So what I have to do? What I have to do?
Applying summation.
Okay. Where I have to apply summation? Where I have to apply summation? If I apply directly summation here, what I will get? Yt plus zt is equal to I want to prove summation is linear. I want to prove this one. I want to prove A. How to prove? We know that what we know that delta yt
White.
plus zt is nothing but delta yt plus delta zt. We know this. And I want to prove summation yt plus zt. Can anybody think of how I will proceed? Similarly, using also to prove B, we know that delta d of yt is d times delta yt. So from that I want to prove summation of this summation. Can anybody tell how many are there? 20 participants are there. No? If I apply summation on both sides, what will happen? I want consider LHS. Okay, I will consider LHS. I want to show LHS is equal to RHS, right? LHS is what?
Yes.
Summation yt plus zt. Now, I want to prove it is summation yt plus summation zt. And using this, you can think on this today. Tomorrow you tell me. It is very easy. Just you have to use this formula. Once you Once you know this, these all three you can easily do them, because it is just follows from product rule of that difference operator. Summation we have to apply just. But first, where to apply, that is that you have to think. Okay, so think on this today.
Okay, ma'am.
Okay.
It is very easy if you just. Okay, so today we will stop here. And tomorrow, I think tomorrow you will only tell me all the proof. 1 or 2 minutes you will require to click this. Okay, so we will stop here. Tomorrow we don't have lecture, no, Monday. Is it? So we will stop here.
Okay, ma'am.
Okay, ma'am. Thank you.